Hey, in this video I want to introduce enumerations. An enumeration is a user-defined set of named integral constants called enumerators. Now these enumerators are typically related and have a particular order. If you're interested in game development, enumerations are really handy for that, for keeping track of states. Let's say you have a game and you have a difficulty for that game, easy, normal and hard. Then you can do a check if the game is easy or in hard mode. Then based on that, maybe it will spawn more enemies into your level or something like that. Or maybe if it's a guessing game, maybe you have to do an extra character, I guess an extra character or something like that, if it's in hard mode. Okay, so you can keep track of the state of things for your game using enumerations. I have a quick example for the syntax of an enumeration definition. You use the keyword enum instead of class or struct as you have before, but this is also a user-defined type. Okay, so you define it first. Basically you provide the blueprint similar to what we've discussed before with the struct and with the class, but in this case you are specifying a list, basically a list of names or a list of states. You're going to provide an identifier name for your enumeration, just like you would provide a class name or a struct name, such as the vector struct or the player class in previous examples. One thing that's important to understand is that the enumerator list is a set of named integral constants. In the example below we have enum E difficulty. I started off with the E just to make sure that we understand that this is a enumeration. This is an Unreal Engine convention. I'm just going to use it here because it's easy. Now in this E difficulty enumeration, I have 3 items in the list. I have easy, normal and hard. Now just like with arrays, we are going to start off with 0. So easy is going to be at position 0. You can also think of easy as being a constant with the value of 0. Normal is basically a constant with the value of 1, and hard is going to be a constant with the value of 2. Now of course it's easier to use these integral constant names, these descriptive names, instead of using 0, 1 and 2 to represent the difficulty of our game. So that is really where enumerations are useful. You can actually specify the value of the integral constants, and you can also specify the integral type, so whether it's a short or an integer for example. You can do that following the enumeration name or identifier. You do a colon and then the integral type. Notice that the enumerators are a comma separated list that goes in the body of the enumeration. We end the definition of an enumeration with the semicolon, just like with structs and classes. Here's the difficulty enumeration example in Visual Studio. I prefix this with an E for enumeration. We use the keyword enum instead of class or struct. Again, this is also a user-defined type as I mentioned. Here is the body. This is a comma separated list of integral constants. I have easy, normal and hard in this example, and as normal you can end that off with a semicolon, just like for the class and for the struct. Now just like with the class and with the struct, we have to instantiate an enumeration. So in main, that's what I do here. I do E difficulty, so I call that difficulty, and then I can assign that. Notice how I assign it. I use the fully qualified name, so I do E difficulty, the scope resolution operator and normal, and then I can also print out, so I can do console output difficulty and I can print that out. Build and run and that prints out 1 because I have it set to normal. Remember, just like with an array, this is going to start with 0, so it's 0, 1 and 2. The next thing I'd like to note is if I go and remove this fully qualified name here, I just specify normal. That would work too. Let me just change that to something else for this example, so I have it set to easy now. So we initialize the enumeration difficulty to easy. And then I do console output difficulty, and that will print out 0. I can actually also do this console output to normal, and then end line. That again should print out 1. So as you can see, this is quite different from what we are used to with structs and classes, where we would have to do some member accessor, or we would have to fully qualify the name. These are unscoped, so in other words, they are available outside of the body. So you can see that is a bit strange. I'll just go and remove this right here. Now if you think back to the switch for a second, you will remember that the switch works with integral types. Okay, so we can do switch on difficulty. So what I did was I typed out switch, I pressed the tab key, and then I entered difficulty. And then sometimes when you click it will go and finish all of the cases for you because it recognizes all of the available cases for that enumeration. On case easy, we can do something, on case normal and case hard. And of course, you can type all of this out manually as well, but sometimes Visual Studio helps us along. We can print things out, or we can set a value. In this case, I'm just going to print out easy, normal, or hard, depending on what it is. And then for default, for the default case, maybe it's an illegal choice or entry. So remember, we set this to easy now. Let's build a run. And it prints out easy as we would expect. And let's set that to hard. Build a run and it prints out hard. Okay, a few more examples for you. I changed the name here to E game difficulty, and I'll be using that in upcoming examples. And what I'll also do is, I'll open up the body of the enumeration like this, and then following each comma, I'll go and press enter. This makes it easy to read. The first note here is that every enumerator, so every constant name, must be unique. So let's say you have a huge list of enumerators. Maybe you end up having the same one near the end, and you've forgotten that you've already added that one. Control and B to build, and you'll get a failed easy redefinition. Okay, on line 9. The next thing is you can explicitly set the value of the enumerators. So for example, if you don't want to start at 0, easy is going to be set to 0 by default. So we can change that. Okay, so in this way we set that to 1. You can think for a second what is going to happen to normal. Okay, what is the value of normal going to be? Well, let's go and print that out. Actually, I'll just print out all three of those. I'll print out easy, normal, and hard. Build and run. And you'll see we get 1, 2, and 3. Next, let's change the value of normal to something like 55. Build and run. And as you might have expected, we start off with 1. So the constant easy is 1. The constant normal is 55. And the constant harder is going to be incremented to 56. So I'm going to set the enumerator hard. I'm going to set that constant to 55, which is the same as the normal one. Now I'm just showing you this because, as I mentioned, the enumerator names should not be duplicated. So in other words, your enumerator name should be unique, but the values can be duplicated. So normal and hard now has the same value. If we build and run, you can see that is fine. Prints out 1, 55, and 55. Now where might this be useful? Well, you can do calculations with this. As an example, let's say you play on easy and you beat the level on that difficulty, then you can get 1 point. If you beat it on normal, let's change that to 3 points. Let's say you beat the level on hard, then you get 5 points. You can do some calculations. So here I have an if statement. If the game difficulty is normal, then console output. So I just print out the value in this case. Build a run and we get 3 printed out. And you can do other things with that as well. So let's say you want to do minus, let's say normal minus easy, for example. You can do calculations and we should get 2. Build and run. And it prints out 2. So the point is you have a lot of flexibility with these. You can do calculations, you can do checks, and you can also actually return enumerations from functions as well. For example, remove that and do a function that returns a type of E-game difficulty. Alright, just a simple example. It returns E-game difficulty again. the name is points collected. It takes in an integer called points, and based on the amount of points, I'm going to return the enumeration. This e-game difficulty, so I'm going to return easy if I've collected 1 point, or normal if I've collected 3 points, or hard if I've collected 5 points. Now you can define another enumerator for the else, but in this case I'm just going to choose easy for the else part, and just as a quick demo. And what I can do here is I'll just use it here as a quick example. So points collected, I pass in 5, and I'll print out game difficulty again. We'll run that and we should get 5. And if I pass in some other value such as 4, then we should get 1 printed out. As you can see, if we set this to 1, then we should also get 1 printed out. Alright. It's best in this case to fully qualify the name, so these returns, what you want to do is, right, you want to do that e-game difficulty, the scope resolution, and easy. And that one as well. You want to get into the habit of qualifying those names. This is a quick example for you to show you that you can return by an enumeration type as well. So we have unscoped and scoped enumerations. In an unscoped enum, the enumerators are visible outside the scope in which they are declared. So an example of an unscoped enumeration definition, enum e-identifier, and you can specify some integral type and the enumerator list in the body. Then we have the scoped enumeration definition. Now with this we must fully qualify the name to access the enumerator, because the enumerators are not visible outside the scope in which they are declared. Alright, and you can see the main difference here is we do enum class and the identifier, as opposed to just enum and then the identifier. And you can also specify the integral type as with the unscoped version. The scoped, also referred to as the strongly typed enum class, was introduced in C++11. Also note that with the scoped enumeration, I'm using enum class and then the identifier, but of course you can use enum struct and then followed by the identifier, because again class and struct are basically the same in C++. You can also do forward declarations with these enumerations. In C++11, again we have unscoped and scoped enumerations. So with the unscoped one we have the enum keyword, the identifier, followed by the integral type. Whereas with the scoped one we are going to do enum class again, so both keywords, followed by the identifier. Now enumerations will default to an integer unless you explicitly specify the integral type. In this example I have the e-game difficulty example again, easy, normal and hard. But then I also have e-terrain difficulty. Let's say in our game we can have different types of terrain and they can be easy, normal or hard to traverse, such as mountain areas, woodlands and so on, depending on your game. And based on whether the terrain is easy, normal or hard to traverse, you can set different values to those which may slow down your movement speed, for example. Now as you can see we have these two enumerations and they have the same enumerators. So in other words, we have duplicated enumerators, such as easy and easy, normal and normal, hard and hard. And if I Control and B to build, this will work fine, because this is a scoped enumeration. We do enum class e-terrain difficulty, but if I remove the class keyword, then this is no longer a scoped enumeration, it is now unscoped. So in other words, the enumerator easy of e-game difficulty and the enumerator easy of e-terrain difficulty will have a conflict. Control B again, and you'll see all of these errors. Easy redefinition, normal redefinition, and hard redefinition as well. Okay, going back to the main function, you can actually see the green squiggly which I ignored in previous examples. If you hover over that, the enum type e-game difficulty is unscoped. Prefer enum class over enum. So in other words, it prefers the scoped enum over the unscoped enumerations. That is not a warning, it's just an IntelliSense thing. Okay, we have the instance right here, game difficulty, of type E game difficulty, and I set that to normal by qualifying the name. And then we have the scoped one, E terrain difficulty. I instantiate that, I call it terrain difficulty, and I qualify that and I set that to normal. Okay, now I can go and use those, so I can do a check, for example. If game difficulty is normal, then I'll just print out normal. So I can do that with the unscoped one. Here again, you can notice that I'm not fully qualifying the name, I'm just specifying the enumerator normal. Build the run and we should get a normal printed out. Now let's say I try and do that with the scoped one, terrain difficulty. Control C and Control V to paste over. If terrain difficulty is normal, and you'll already see a red squiggly, no operator matches those operands. So what I have to do is I have to qualify that name. So I do E terrain difficulty, the scope resolution operator normal, and that should work fine. I can build a run and we get a normal. So as you can see from this example, the enumerators of the scoped enumerations will have to be qualified. The scoped enumerators are only visible within the scope where they are declared, whereas the unscoped enumerations, the list of enumerators that it'll have, will be visible outside of the scope where they are declared. I'll just remove this here. As we've seen, we cannot do something like this. With a scoped enumeration, you have to fully qualify the name. Like that. E terrain difficulty, normal. So I have this X variable, and what we can do now is we can assign normal to that. So we can assign normal to X, or you can fully qualify the name as well. So we can do that, E game difficulty, and I'll set that to normal. So X should now print out 1. Now let's try and do the same thing with the scoped version. Try and assign E terrain difficulty normal to X, and you can see we get an error. Can it be assigned to entity of type int? Of course you can try and build that, Control B, and it'll fail. So the point of this example is that scoped enumerators must be qualified, that is by the type name or identifier name of the enumeration, and they can also not be implicitly converted. But what you can do is you can explicitly convert. So here, for example, how do we cast or convert? I talked about this previously. Between parentheses, you put what you want to convert to. So I want to convert to int, and I'm going to convert this thing right here. The enumerator or constant normal, I'll convert that to an int, and then I'll assign that to X. Now I can build a run, and we get 1 printed out. Unscoped enumerators will be implicitly converted to an integer, but the scoped enumerators will have to be explicitly cast to an integer or whatever type, so a short or whatever you have. The integral types, you can specify the type again over here. Int, for example, you do a colon and then the type. The main reason for your scoped enumerations are to avoid those implicit conversions. Okay, and in that way you can often eliminate programming errors. Copy this or cut that out. You cannot do this right here, you'll get an error. Now operator matches those operands, so I cast that to an integer and then that'll print out fine. Prints out 1. Again, with the scoped one you have to do explicit conversions. Of course you can change enumerators later on, so you can do. You can choose e-game difficulty, easy, and so on. You can change that later on. It's the same with the scoped and the unscoped ones. You can do easy, hard, and normal, so you can change them later on. But let's say for some reason you want to assign an integer to this, for example. Let's say do something like 3. I'll just comment this one out here for a second. You cannot do this. You cannot assign 3 to this enumeration. Right, a value of type int cannot be assigned to an entity of type e-game difficulty. Actually, I'll just change that value to 2, and then here convert 2 to a type of e-game difficulty. And it's going to be the same here for terrain difficulty as well. You're going to have to cast that to e terrain difficulty. Then just for demonstration purposes, I'll go and print those out. Game difficulty and terrain difficulty, which I'll cast to an int. Build and run this, and we get 2 and 1 printed out. Of course, you can go and write these checks. If the game difficulty is hard, then print out, let's say we print out hard, and that should be because 2, okay, we start with 0, so E game difficulty 0, 1 and 2, so this is now set to hard. If the game difficulty is set to hard, then print out hard. Build and run, we get hard printed out and 1. Okay, so you get the point here, you cannot simply assign an integer to an enumeration. Whether the enumeration is scoped or unscoped, you have to cast. Also, there are different ways of casting. This is sort of an old way of casting. I'll talk more about casting and conversion in a future lesson, but for our purposes for right now, this works fine. Casting in this way. Okay.